Rajat. How are you doing?
Good. How are you?
Good, good, Rajat. So you have an interesting profile, Rajat, and I must call you Mr. Dr. Rajat Gupta because not very frequently do we actually talk to a lot of actual PhD holders. We have a lot of people a lot of learners who are doing PhD, but you are actually a PhD holder, and also you are not just any PhD doctorate, but you are actually a scientist working with CERN in Geneva. So very glad to have you as part of our data and AI programs in IvyProSchool. Welcome to the program, Rajat.
Thank you.
So, Rajat, looking at your profile, I thought we talk to a lot of people. We have got many types of profiles of learners in Ivy, but very rarely do we get actual scientists, specifically from such a metaversial word, if that at all is a word. So I thought, it would be interesting to hear your perspective as a proper research scientist, right?
Mhm.
How do you use data? And I want to understand your story as well. How did you get into this world? And I understand you're from Punjab, so I would like to understand how your journey was, and then we'll come to the program as well. Why did you choose it and so forth? But yeah, let's start with your journey.
Okay, so so I did my all of my studies in from Punjab University, Chandigarh, and our group in Punjab University, Chandigarh has been historically involved in particle physics. Uh, I think one of the major discoveries in 1991 or 1992, uh, our professors or faculty were involved in the discovery of W or Z bosons, so which was a very major discovery in particle physics. And other than that, our group has been historically involved with the collaboration from CERN in Geneva or Fermilab in US. So so it kind of motivates when you were studying, doing your bachelor's or doing your master's. So I always had an intention of doing my master's project in particle physics. So I joined as a so my master's project was in particle physics, where I was supposed to do some fabrication of muon detectors. I think at that time my master project was to build some resistive plate chambers for the INO project, which was supposed to happen in in Madurai in the South India. So we were making some muon detectors. And then I think by the time I completed my master's, I was pretty clear that I want to continue in this. So I started doing my PhD from Punjab University. And so I think as a PhD student, when you enter into particle physics, one of the major thing which most of the PhD student does is the data analysis. And uh, I mean, I did not know about it until last year when I joined Ivy School. That the data which I have been working with from last 10 years is actually called big data. So, so I mean, I did not know the
And
terminology
and
because
you actually work with really large data, is what you were telling me, right? Give us some
yes,
idea of the volume of data that you deal with.
yes. So we have the 27-kilometer long tunnel, and we collide the protons as at the energies of tera electron volt, around 13 tera electron volt, and we create a Big Bang like situation in our experiment. And my numbers could be really wrong, so I won't talk about the numbers, but we collide. So there are like 1800 collision of proton bunches happens every few microseconds. So there's lot of data collected, and we have various tiers of storage capacities in all over the world. We have tier 0, which are located nearby in the Europe, at CERN, in Germany, in France, or things that. Then we have the tier. So we filter out some data from tier 0, then we shift it to tier 1, tier 2, and tier 3. And the data is actually too large. We use some hardware triggers just at the readout of the detector, just to filter out only just to filter the interesting physics things out of it. Because if we start storing all of the data, in spite of having so much huge storage site all over the world, if we start storing all of this data, I think our storage sites will be full in almost 3 hours. So that's the estimate. So yeah, exactly. We deal with a very big data, and we have to implement various machine learning models or various physics algorithms to filter out what events are helpful to us, what not. So we filter out this data so many times. We have hardware level filters and software level filters which we implement. In spite of all those triggers and filters, we still get a lot to deal with. And after that, we have some physics theoretical models, and we get this data in form of some inbuilt it's in the format which our inbuilt software or the software which we use, the framework which we use are of CERN proprietary. So these frameworks are mostly based upon C++ and Python.
Hmm.
So we write some C++ and Python scripts to analyze the data and then compare it with the physics theoretical models which we have. Some physics theoretical models which are not discovered yet but have been in theory since many 50 years or 100 years or things like that. So we try to compare, so we analyze the data and we produce some nice plots. We try to make some good story to actually, so we have to first validate the data which we are getting. And then we try to make out some results out of that data. We analyze it and then compare it with the theoretical models. There are some statistical tools which we use to compare it with theoretical models because we have to know the precision, because there could be many experimental or theoretical uncertainties involved with the data or the analysis results which we are producing. So we have to make sure that the comparison with the theoretical model has to be, so we have to involve those uncertainties, uncertainty in the experimental detection, because it might be possible that the energy which we detected from the detector, it's not the precise energy. There might be some uncertainties related to the detector. Maybe the detector was not able to detect the energy precisely. So we have to take those uncertainties as well. So we have to use a lot of statistical tools to deal with this. And in case, uh, in case after considering all those uncertainties and all that, if our analysis actually agrees with some theoretical model, then of course there's a discovery.
Absolutely.
Otherwise, we can say that.
But you were saying that, the discoveries are rare, right? I
Yes,
mean, it's not like,
it's very rare. So, for example, I think 2011 there was a major large discovery
I
which got a Nobel Prize. It was the discovery of Higgs boson, which we also called God particle.
Mhm.
And so, even the occurrence of Higgs boson is very rare. It's like one event in many million events. So
Oh, I
that's
see.
how rare it is. So
So you told me that you're working with dark metal in dark energy, right? I mean, so that's this boson thing is what kind of
So I think it was theoretically known in 1950s or 60s by some US scientists, I guess. At that time, when they were discovering the speed of the universe, speed of the Earth universe, they realized that the speed with which our universe is rotating is uh, not not what they are expecting. So then they realized that it's only 3% of what we saw in right now. There is some 97% which we do not know in what form it is. It could be in
right?
another dimension or it could be anything. So there are some various physics models to know, because when the Big Bang happened, so why it happened that only 3% of the matter is only visible to us, but what happened to 97%? So that's the reason we, in our experimental lab, we create such Big Bang like situation to actually know the history from the starting point until now, like what happened to that 97%, but so right now why do we only see 3%, and in what form that 97% went, and if it exists, is it in another dimension, and that's why we are not able to see it or detect it, or is it in some another form? So that's what I'm trying to do. We have some theoretical models uh, where we talk about the existence of dark matter or dark energy, and that's what I have been trying to do.
Very good, Rajat. So, Rajat, I want to understand. I mean, you told me that from Punjab you went to University of Pittsburgh, and now from University of you are actually an employee of University of Pittsburgh, and you are contractually available in CERN, Geneva, right? That's the story. I also want to understand from you, right? Uh, for a scientists like you, right? You ended up deciding to do a program, I mean, a data and AI certification program with Ivy Pro. What made you choose this particular program and at Ivy? I mean, was there any student who recommended you, or how did you find us?
Okay, I was just going through I mean, so when I decided to do switch to industry from academia, I mean, it's just I'm just keeping it as an option if I want to switch to an industry, and there were various reasons because I decided to switch to an industry. So I was seeing lot of YouTube videos. I was going through lot of Reddit answers, core answers, and everything. I was reading the comments from the industry people and all of that. And I mean, in fact, if you start Google anything like I want to do data science course, so you will see big website links where they will say that uh, data science course in collaboration with this university in US or this university in Australia. So, I mean, naturally you get very inclined towards doing that. So, because you always have a thing like, okay, I will get a data science course degree in collaboration with the university in Australia or the university in US. So, I mean, you are keen to spend many lakhs of rupees to do this. But I wanted to make sure that whatever I want to do is worth I worth the money or the time I spent to. So when I was reading all of the comments or the from the industry people who recruit, so I came to know that in the industry, if you are applying for a job, it's not like academia uh, where you get selected on the basis of what your marks you get in 10th class or 12th class or BSc, whether you were a university topper, whether you have PhD or not. So I think that's what I came to know that in industry, it doesn't matter whether you have whether you have a course or degree from this university or this university. I think it's what it matters is the projects which you have done in all of your in all of that time, what kind of projects they are, whether they are impactful or not, what your LinkedIn profile where you can show all of those projects, your GitHub projects. So that's what I came to know that industry only care about those things. They don't really care about the degrees which you have. And so I think I just came to know about Ivy Professional School. It was very random. I think I was just only Googling through it, and I think another reason I would definitely say that because I had an option to do it from YouTube or some other free websites where I could do it, but I wanted to learn it in a class environment where we can get some assignments, where we can get some industry projects to do. So the reason of choosing Ivy was also that okay, I think the course fee was not that much high, so I could afford. I mean, I thought that okay, maybe I can give it a try. It's not that expensive, and I would learn something. So that's what I wanted to do. I did not want to earn any more degree. I think with PhD, I'm almost done with my degrees already. So the getting a degree was not an idea, but getting exposure of industrial projects, how the different projects are being done in the industry. Because I was always limited to the data analysis or the machine learning things which I have been doing. It was in the area of science. So I
Mhm.
was not aware what kind of what kind of projects are being done in the industry. So that's the kind of exposure I actually wanted to get. And I think currently I
Rajat,
have.
I understand that you spent like 3, 4 months with us already. So what's been your experience?
So I have done the Excel course, and it was like really, really helpful for me. Not only this, because like I said, I use data analysis anyway. But the Excel course which I did, it really helped me. Now, even when I do my own research, sometimes I use those Excel advanced functions in my own research work to do some things which I don't sometimes I feel like I don't if I have a structured data, I don't feel like just writing a new script, Python script, or
I
new C
know.
plus script. I can just put my data in the Excel and use some advanced Excel functions to do it. So I think sometimes it's very useful rather than writing a full script. So it's very helpful, and I did not know, honestly, before that I did not know that Excel could be that powerful. So that was something new for me, because and now currently I'm doing SQL course. It's been really amazing. I have been taking this course from you. So
And I know I know because you're one of my students as well. I know you take special interest in doing cases and projects, and we give quite a few of them. So I mean, how do you manage to get time for doing cases and projects with you with your work?
yes, so I mean that's a bit difficult to do, honestly. What I try to do is, so the classes are on weekends, so usually my weekends are mostly free. And even in fact in the weekends, so currently like the SQL class which I'm taking is from 2 to 3 p.m. 2 to 4 p.m., right? Or 1 to 3,
One,
from
two,
1
three. Yeah.
so it's like 8:30 a.m. for me. So I
Ah,
usually get away with my class very early in the morning. Like by the time I actually get up from the bed, like by 10:30 a.m. I'm done with my class. So I have like whole day to do the homework which I get, the case studies which I get. And I recently got this data scientist salary project from you. It
hmm.
was interesting to do. I was able to do it. It was quite interesting to see the salaries of the data and data scientists, and how it varies with the number of programming languages, or how it varies with the region where you
Hmm.
are located in the US. So it was very quite interesting to know, because
Hmm.
that's what I'm trying to do to the job or something. So
No, no, I understand that, Rajat. And Rajat, I mean, I know you mentioned that we got like 16 fundamental particles in the world, and I thought you want to add. I think data is also a particle for you now. I think that's what you are. I think everybody is utilizing, and you're also utilizing. I think that's where you're trying to go towards, right? You're utilizing a lot of information and data to discover new things, Rajat, right? So, Rajat, I mean, very interesting profile that you have, right? We do not actually come across with people who are actually doing such kind of scientific research. So, my good wishes for you, and I'm sure you'll do great in the program. And also, I feel that the path or the planning that you've done for your career, with your solid academic background and theoretical physics as well, and of course, you've been toying with machine learning techniques, and now that you are part of this program, so you'll also learn Gen AI, you'll also learn various data slicing, dicing, data science techniques essentially. So your profile with academics and the vocational skills of this Ivy Pros program, I think, and you'll end up working on 30 plus, 40 plus projects or something. So I think that plan, right, that you marry your academic experience and profile with vocational data science and data and AI techniques and tools. I think that plan is great plan, and Rajat, and I'm sure you will do great, and it's an honor to have you as part of the program, Rajat.
thank you.
Thank you, Rajat. Have a good day. Bye bye.